In this video, we will be looking at 6 basic functions, most of which you should be familiar with. So let's start out with our basic linear function, y is equal to x. Now we should know that the domain is all real numbers. We also should know that it's in the form of y equals mx plus b, so we should know that the slope is 1 and that the y-intercept is 0. But let's for a minute pretend we don't know all of that. How would you graph y equals to x if you did not have this prior knowledge? Well, when you're looking at graphing something new, let's make a table of values. The easiest value, of course, is 0. When x is 0, y is 0, because they are equal. So if x is 1, y is 1. If x is negative 1, y is negative 1. And again, we could continue this process forever because, of course, the domain is all real numbers. So this should be a line, of course, with a slope of 1. And that's our basic linear function. But before I go to the next graph, I want you to keep in mind those 2 points. You'll see in a minute. Let's look at our quadratic function. We've looked at this in the past. We know its shape. We really do know how to graph it. But let's just review that, of course, the domain is all reals. We know it has a shape of like that. We know its vertex is 0, 0, and so forth. But again, let's go back to the basics. If we were to build a table of values, if I put in 0 for x, then 0 squared, of course, is 0. If I put in 1, 1 squared is 1. If I put in negative 1, remember, we're going to square it, I would get positive 1. 2 squared is 4. Negative 2 squared is also 4. And we get the parabola that we know. And of course we know the graph looks like that. And again, those 2 points are in common with our linear function. Let's look at one more graph that we've already studied, absolute value. Again, we should know that the domain is all reals. We know it has that V-shaped. We've talked about the vertex in the past. But again, we're going to go back to the basics of establishing a table of values. Okay, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of negative 1 is positive 1, and that's where we get that V shape. The absolute value of 2 is 2, and so forth. So it has some characteristics of our linear function in that this branch of our absolute value is the same as that half of that line. It also has some similar characteristics to our parabola in that it has an up on both sides. But again, they share those 2 points. But what about our square root function? Now that's something new. What is our domain? It is not all real numbers. Remember, if we're taking the square root, whatever we're taking the square root of needs to be greater than or equal to 0, so we don't have imaginary numbers, that we are staying in the real number land. So as I build my table of values, I can only choose 0 or positive numbers. The square root of 0 is 0. The square root of 1 is 1. Now I'm going to choose some easier numbers. What about 4? I know that the square root of 4 is 2. And if I were to choose one more, like 9, the square root of 9 is 3. 1, 2, 3, that's 4, 5, 6, 7, 8, 9. So way out here at 9, I would go up to 3. And so what happens is, if you think about it, it should look like a half a parabola or a half a quadratic turned on its side. So our domain is different, but we still have those two common numbers, those two common points. What about a cubic equation? Y is equal to x cubed. Well, the domain, again, is all reals. Do we know what that looks like? Not yet. So let's build that table of values. And yes, we're going to start out with 0. 0 cubed is 0. 1 to the third power is 1. Negative 1 to the third power. What is negative 1 to the third power? Well, that's negative 1 times negative 1 times negative 1, which of course is negative 1. Well, that looks like our linear function, but we know it's not because of that exponent. So what about 2? 2 to the third power. That's 2 times 2 times 2, which is 8. So over here, 1, 2, 3, 4, 5, 6, 7, way up here at 8. Negative 2 cubed is going to be negative 8. So what it's going to look like, something like this. If I were to continue, 3 cubed is 27, and I'm way out of space. But you can see it does have some symmetry. Remember, we talked about earlier that this is an odd function, so it's symmetrical with respect to the origin. But look at there. It has those same 2 points in common. Well, if we're going to cube something, can we cube root it? Well, let's look at the domain. You might think, oh, that is only greater than or equal to 0. No, because of the cube root. This really, the domain is all reals because you can take the cube root of negative numbers and positive numbers. So again, the cube root of 0 is 0. The cube root of 1 is 1. The cube root of negative 1 is negative 1. But just like on the square root, I chose some easier numbers. I'm going to choose easier number here. The cube root of 8 is 2, because as we saw earlier, that 2 cubed was 8. So if you go backwards, the cube root of 8 is 2. All right, so if I go way out here at 8, I would come up at 2. So I've got this part. And if I choose negative 8, I'm going to get negative 2. So way over here at negative 8, negative 2. So kind of like the cube function, kind of turns sideways, upside down, but you should see some relationship between this function and the last.